Are the following graphs functions? In order to be a function, we must pass what's called the vertical line test. When you draw a vertical line, we can only cross at most once. So this here indeed is fun. This is a function. Yes, because we drop a vertical line, we only hit once, so this is a function. What about B? We drop a line here, we only hit once, so yes again. We drop a line anywhere, even here, we're only going to hit once. So indeed, we'll say yes, this graph is a function. Now what about here? This looks like a parabola, but sideways. When you drop a vertical line, this hurts. You hit more than once. So this is not a function. Not a function. We fail the vertical line test. Now what about this graph over here? You drop a vertical line, we only hit once. We drop a vertical line here, we only hit once. We drop a vertical line anywhere, we hit at most once. So we say yes, this is a function. However, this function is not defined at x equals 0. This here we call a vertical asymptote. Now what about this sinusoidal curvy function over here? Is it a function? We say yes, we hit at most once with a vertical line test. So yes, this is a function. What about the circle? When we drop a vertical line, this hurts. This is not fun. This is not a function. Although we have only one hit going on the edges here and here, anywhere in between, we fail the vertical line test. This, however, is called a relation. We have a relationship between x's and y's. It is a relation, but when we're talking about functions, functions are on the inside, whereas relations encapsulates functions. Now what about this piecewise function here? Does it pass the vertical line test? We say yes here, but what about in the middle? Indeed, we do pass a vertical line test because there's a hole here, so we go right through it. We only hit once here on this point, so we say yes, this is a function. It's a piecewise function. And finally, this looks like a function because we're only hitting once. However, in the middle at x equals 0, we hit once here, and again we hit twice here. This here fails the vertical line test, so this is not a function. Evaluate f of negative 3 given f of x equals x squared. This means y equals x squared, and we're going to substitute. We're going to replace x with negative 3. So we have f of negative 3 equals something squared, and that something is the x value, negative 3. Negative 3 times negative 3 is 9. So f of negative 3 equals 9. Now let's evaluate f of negative 3 when f of x equals x squared minus 2x. This is called function substitution. We replace x with brackets, and so we have something squared minus 2 times something, and we replace x with negative 3. Negative 3 squared is 9. Negative times negative is positive 6. 9 plus 6 is 15. Now let's try this challenge question. Let's evaluate f of negative 3 given this function is quite complicated. We replace every occurrence of x with negative 3. So we have 3, negative 3 cubed minus 2 to the something, which is negative 3, all over 5 times negative 3. Working at one part at a time, we have 3 times negative 27, and we have a minus sign here. 2 to the minus 3 is 1 over 2 to the 3, and we have divided by 5 times negative 3 is negative 15. What's 3 times negative 27? It's negative 81. We have minus 1 over 8 times negative, the reciprocal of 15 is 1 over 15. We have negative 81. We have plus, because the negative times the negative is positive, 1 over 8 times 15 is 120. Make sure you multiply first before adding or subtracting. The final answer is negative 9719 over 120.